All right, so this is 3.7a continued. And am I on number 5?
Yeah.
Okay. Thank you. So for number 5, what we've got is 2xy plus pi times the sine of y equals 2 pi. So there's the equation. And then they're going to tell you that there's a point at 1 pi over 2. And the question is, find the equation of the tangent line. At the given point. So we got 2xy plus pi times the sine of y equals 2 pi. Given us this point, we're going to find the equation of the tangent line at the given point. Okay, so if we're going to find the equation of the tangent line, we need the slope of the tangent line. And in order to find the slope of the tangent line, we have to take the derivative. When we take the derivative of this, what technique are we going to use? Chain rule, disguised chain rule, implicit differentiation, whatever you want to call it. It's the technique you use when this is not solved for y. So since this equation is not solved for y, we're just going to take the derivative straight up the way it is. So just put a d dx around it, and that means take the derivative. And this is called implicit differentiation. Okay, so for this, it's going to be product rule, because we got 2x and y. So the derivative of the first thing is 2 times the regular second thing plus the derivative of the second thing times the regular first thing. So all of that is the derivative of that. Then for the derivative of this, the pi is just hanging out. It's a constant. So plus pi. But the sine of y is a chain rule. The outside function is sine. Derivative of that is cosine. Then you plug regular inside into it. And then multiply by derivative of inside. So that's the derivative of the sine of y. And then 2 pi is a number, so the derivative of that is 0. Yes?
Did you take the derivative of pi too? Or no?
Not really, no. So when I did the derivative, this is a good question. So when I took the derivative of pi times the sine of y, that was just a number, so I brought it out front. Now, I could have treated that as product rule, but then it would have been 0 times something, and then that derivative times pi. But it's easier to just pull the constant out front. Good. Yeah, it's interesting. When I write, that's the way I wrote it down originally, and so when I write it that way, you're like, oh yeah, because it jogs your memory. So that's good. Okay, so let's see. This has a y prime, that has a y prime. This is the only one that doesn't, so I'm going to move it over there. So that'll be y prime times 2x plus pi times cosine of y times y prime equals negative 2y. So just subtracting that to the other side. And then I can factor out a y prime. So it's y prime times 2x plus pi cosine y. And then divide that over. So it's y prime equals negative 2y over 2x plus pi cosine y. So there's the formula for the derivative. I'm interested in the slope at this point, so now I'm going to plug that point into there. This is a little bit different. We're not used to equations that have both x and y in them, but it's not that tough because we'll just put a 1 in for x and a pi over 2 in for y into that formula. So that'll be y prime equals -2 times pi over 2 divided by 2 times 1 plus pi times the cosine pi over 2. So I just stuck a pi over 2 in for the y's and a 1 in for the x to find out the slope at that particular location. On top there, the 2's will cancel, so that's -pi. On the bottom, 2 times 1 is 2. And then for the cosine of pi over 2, we can look at the unit circle. So here's the unit circle. Here's pi over 2. That's 0, 1. To get there, you go 0 and then 1 up. And then remember, the cosine is the x value, so the cosine is 0. So that's pi times 0. So the slope comes out to -pi over 2. Okay, so that's the slope of the tangent line. So that goes in for the m in the equation for our line. And then to find b, you just plug in the point. You put a 1 in for x. So -pi over 2 times 1 should output pi over 2. So I just put a 1 in for x and a pi over 2 in for y again. Try to figure out the y-intercept. So that's -pi over 2 plus b equals pi over 2. And I add that to the other side. So pi over 2 plus another pi over 2 is 2 pi over 2. Because you have a common denominator, you're just adding fractions. They have a common denominator with 2, so you just add the tops. And then the 2's will cancel, so b is pi. So y equals -pi over 2x plus pi is our final answer for the equation of the tangent line. Okay, what if it went on and said find the equation of the normal line? How would you go about doing that? Yeah.
The slope would be the opposite.
Good. So the slope here was -pi over 2. So the slope of the normal line would be +2 over pi. And you do the same thing. You put a 2 over pi here, find the new y-intercept. Don't forget the normal lines and tangent lines, most of the time they have different y-intercepts, right? So you have to go back and find the new y-intercept. All right. There's one more question in 3.7a. This is number 6. Got x plus the tangent of x over y equals 0. Okay, and what we're trying to figure out is dy dx like normal, the slope equation. Okay, so derivative of x is 1. Then this is not even a disguised chain rule, right? It's just a regular chain rule. It's very recognizable that that's a mess inside of tangent. So the outside function is tangent. Derivative of that is secant squared. So there's the derivative of the outside. Then you put the regular inside into it. So there's the regular inside plugged into it. And then you take all of that and multiply by the derivative of the inside. Now this time the inside function is x over y. So when we do the derivative of that, we have to use quotient rule. Since the inside is division, we use quotient rule to do the derivative of the inside. Okay, so derivative of the top times regular bottom minus derivative of the bottom times regular top, and then all over the bottom square. So all of this is just the derivative of x over y. Everybody okay with that? Okay, and then derivative of 0 is still 0. So that's that side. Okay, now I'm going to subtract the 1 over. So I'll have all of this equals -1. And then I'm going to clear the fractions. So since it's divided by y squared, if I multiply by y squared on both sides, that'll get rid of the fractions. So that'll cross this out. This side will be -y squared. Okay, so what I've got over here is secant squared of x over y times y minus y prime x. And the reason the y squared is not there anymore is because I've multiplied it to the other side. Bless you. Okay, so now I'm going to take this whole mess and divide it over. So that gives me y minus y prime x equals -y squared divided by secant squared of x over y. So the secant squared of x over y was multiplied. So I'm just dividing it over to here. Okay, now when you divide by secant, 1 over secant is cosine. So dividing by secant is the same thing as multiplying by cosine, since 1 over secant is cosine. So this could be rewritten as -y squared times the cosine squared of x over y. Since the reciprocal of secant is cosine, if you divide by secant, that's the same thing as multiplying by cosine. So then I still have y minus y prime x over here. So to finish it up, I'm going to subtract the y. Oops, forgot to subtract the y. So that was just minus y to the other side. And then we're going to divide by the negative and the x to get y prime by itself. So y prime equals negative y squared cosine squared of x over y minus y divided by negative x. Is everybody doing okay? Okay, so I think in 3.7a, some of the harder stuff is the algebra. The derivative, I mean, the disguised chain rule is a little tricky because you might forget about the y prime. You might forget about the disguise in the chain rule. But as long as you remember that, then after that, sometimes getting this y prime by itself is tricky. The algebra is tricky. So we'll probably spend some time on that if you have questions about that. Is everybody doing okay on those two problems? Okay, so that's it for